Hey guys, today we are going to dive into the topic of compound inequalities. A compound inequality contains at least two inequalities and is separated either by an or an and. Compound inequalities can be used to describe real-world situations, such as the years that a person is not working. For example, most people are not working below age 18 or above age 65. This can be represented by the compound inequality x is less than 18 or x is greater than 65. This states that people, x, generally will not be working at an age that is less than 18 or an age that is greater than 65. This is an example of an or inequality. An example of an and compound inequality could be used to describe something like the years a person is in school. This would generally be between the ages of 5 and 25, and we can represent this scenario with this compound inequality. This would be read as x is greater than or equal to 5 and x is less than or equal to 25. In this case, our solution set has to satisfy both constraints. Remember, compound inequalities can be represented as either an or statement or an and statement, and it can incorporate these symbols. Let's look at some examples. Here's an example of an or compound inequality. This would mean that our solution set is any value greater than 6 or less than or equal to negative 8. Any value that satisfies one of these constraints is considered a solution. Here's an example of an and compound inequality. This would mean that our solution set is any value greater than 45 and less than 49. All values that fall between these two numbers will satisfy the constraints. Now that we have an understanding of what a compound inequality is and what it represents, we can dive into the process for solving compound inequalities. Let's solve for a compound inequality that is separated by an or for our first example. So we're going to solve for z. 5z plus 7 is greater than 27, or negative 3z is greater than or equal to 18. Our first step is to solve each constraint separately. The solving process is the same process for solving multi-step equations. The same rules apply with one exception. When you multiply or divide by a negative, the inequality will flip. We'll see this process unfold as we finish this example. So let's start by solving this inequality. We'll start by subtracting 7 from both sides. That'll give us 5z is greater than 20. And then we divide by 5 on both sides. So z is greater than 4. Now let's move over to our other inequality. For this, we just need to divide by negative 3 on both sides. Remember, when we divide by a negative, our sign flips. So instead of greater than or equal to, we're going to have less than or equal to. 18 divided by negative 3 is negative 6. So our final answer is z is greater than 4, or z is less than or equal to negative 6. This is now in a graphable form that can be represented on a line graph. Now let's check out a compound inequality that is separated by an and. We're going to solve for x. Negative 12 is less than 2 minus 5x is less than or equal to 7. So for an and inequality like this, we can solve for x by doing inverse operations to all three parts. So let me show you what I mean. The first thing we want to do is subtract 2 to get x by itself. So we're going to subtract 2 from this middle part here. But if we subtract it from the middle part, we also need to do it to the left and right sides. So we'll subtract 2 over here, and we'll subtract 2 over here. Negative 12 minus 2 is negative 14. The 2's cancel out, and we're left with negative 5x. It's less than or equal to 7 minus 2 is 5. Now we're going to do the same thing, but divide by negative 5 on all three parts. Remember, when we divide by a negative, we flip our inequality signs. So we're going to have negative 14 divided by negative 5 is 14 over 5 is greater than negative 5 divided by negative 5 leaves us with just x by itself, which is what we're looking for. Our inequality sign flips over here as well. And then 5 divided by negative 5 is negative 1. So our answer for this inequality is x is greater than or equal to negative 1 and x is less than 14 over 5. There are times when you will be working through the process of solving a compound inequality and your result will be no solution. What does this mean? What would this look like? Let's take a look. We're going to solve for x. 5x minus 3 is less than 12, and 4x plus 1 is greater than 25. So we're going to start by solving each one of these inequalities separately. So let's start by adding 3 to both sides of this inequality. This gives us 5x is less than 15, and divide by 5 on both sides to get x is less than 3. Now let's move to this inequality over here. We're going to subtract 1 from both sides. That gives us 4x is greater than 24, and then divide by 4 on both sides. X is greater than 6. So our solution is x is less than 3 and x is greater than 6. But wait, this is impossible. We are unable to find a value for x that is both less than 3 and greater than 6. If this occurs, the compound inequality is said to have no solution. And that's all there is to it. I hope that this video was helpful for you. Thanks for watching and happy studying.